Hi, math students. Today I want to give you a little mini lesson where we talk about the concept of infinity. We're about to embark on limits that approach positive and negative infinity, and without a little background knowledge on how infinity works, those limits can be difficult to understand. So let's just start with the notion of infinity and work with it a little bit. So if you take a look at this first limit I have here, it says the limit as x approaches infinity of 2x plus 3. Let's talk about what we're trying to find here. So what we're saying is, if we graph the linear function 2x plus 3, and we go way out to the right, x is getting very large with no boundary. So that would be pushing us to the right side of the x-axis. So we go way out to the right. What are the y values heading toward? So if I'm thinking of it graphically, I may want to graph 2x plus 3. So I know that has a y-intercept of positive 3 and a slope of 2. So I'm coming up 2 and right 1. So that graph looks something like this. So as I go way out to the right, so as x is approaching infinity, getting larger and larger and larger, so as I'm going out, what are the y values doing? Well, they're going up. So as x goes toward infinity and grows large, it seems that y is also going to positive large. So I'm thinking that the answer to this problem is infinity. Well, if we follow the recipe for limits, we always plug our value in for x. So doing that, I would get 2 times infinity plus 3. Now, the question is, what's that? Well, 2 times infinity. So if you're growing really large without bound, and then you multiply by 2, you're still growing very large without bound. And then you add a measly little 3 to it, I would say you're still very large without bound. So this, to me, would be infinity. So just as predicted, the y values are going up to infinity. Okay, so look at the next one. The limit as x approaches negative infinity of the same linear function. All right, well, graphically, we already have the graph here. So as x comes way back to the left, as x grows very small without bound, so we're now going to negative infinity on the x. What are the y values doing? Well, if you get on the function, you can see that the y values are also coming down. So the y values are growing very small without bound. So I'm going to predict that my limit here is negative infinity. Well, if we plug it in for x, we have 2 times negative infinity plus 3. And again, if you're heading in the leftward direction on the x-axis, growing very small with no bound, and you multiply by 2, you're still growing very small with no bound. And when you add 3, this is going to have very little effect on our front runner here. So I'm going to go ahead and say that is negative infinity. So this just confirms what the graph was showing anyway. Okay, let's take a look at the next one. The limit as x approaches infinity of the quadratic function x squared. Graphically speaking, we've got a quadratic. We've got a parabola with a vertex at 0, so looking like this. So as I go way out to the right, you can see my y values are headed upward. So as x goes to infinity, so does y. Now if I plug infinity in, infinity to the second power, well, infinity is already growing very large without bound. Now I square it, I would say that that's growing very large without bound, infinity. And last but not least, the limit as x approaches negative infinity of x squared. Okay, so let's look at the x-axis. Let's go small. Let's see what the y values are doing. They're going up to infinity. So I'm thinking if I plug this in, negative infinity squared. The same rules apply to infinity here as we do when, in Algebra 1. You take a negative times a negative, you get a positive. So again, this just confirms what the graph is showing. So that's just a little bit about infinity. Okay, next thing about infinity I want to review with you is this, because this is often a mistake students will make. If you ever get infinity over infinity, a lot of students want to say, hey, that's 1. When you divide something by itself, you're going to get 1. So that's the question I posed here. Does this equal 1? Well, the answer is no. And the reason is these are not equal. Infinity is just the concept of growing larger without bound. So who's to say this infinity isn't 1,000,000 and this infinity isn't 5,000? I mean, 5,000 is pretty large. 1,000,000 is pretty large. But since this is just the concept of growing large, we can't identify truly what infinity equals. So if we can't define this and we can't truly define that, then we definitely can't define the quotient. So I just want to make sure you realize that infinity over infinity is undefined. It is not equal to 1. Okay, and then the last piece of this lesson, before we get into the main lesson on the next video, is this. I want to go through a little progression here. So if I take 5 divided by 1, I most certainly get 5. And if I take 5 divided by 10, I get 0.5. And if I get 5 divided by 100, I get 0.05. And 5 divided by 1,000, 0.005. And 5 divided by 10,000, 0.0005. Coming up here, 5 divided by 100,000, 0.00005. And you're kind of getting the idea here. Notice that the numerator is still 5 in all these quotients. What I'm doing with the denominator is I'm letting it grow larger and larger and larger with no boundary. So the idea here is I put a little ... So if this would continue and continue and continue, then I'm going to say that 5 divided by really, really large numbers that are growing without bound is heading towards 0. Because as you can see, these are getting very, very close to 0. Now, what about 5 divided by negative infinity? Well, all I have to do there is start with a -1, a -10, a -100, a -1,000. See how my numbers on the bottom are growing very small with no boundary? Well, what happens? Well, this is negative, negative, negative. But even though they're negative, they're still approaching 0 just from the left side. So both of these quotients are going to be 0. And it doesn't really matter what your numerator is. If your numerator is fixed as a real number and your denominator is heading toward infinity or negative infinity, then your quotient is always going to be 0. Okay, so this lays the groundwork for our next lesson. And our next lesson, we're going to tackle limits at infinity that go a little bit further than sort of these simple limits that we worked on today.